Hi, welcome to section 9495 notes. This is on composition of isometries. So an isometry is a transformation that preserves distance or length. So translations, rotations, and reflections are all isometries. Those are all the ones we've talked about in section 9.1 to 9.3. And what that means is that in all of those transformations, the figure is staying the same shape, it's staying the same size, it's just moving to a new location. It isn't getting bigger or smaller. Okay, so this lesson is also an isometry. The figures are going to stay the same shape and the same size. A composition of isometries is two or more transformations that create a new image. Okay, so in a composition of isometries, the second transformation is always done first. I would star that because that's probably the biggest key thing here. Everything else that we do in this lesson, we've already done in the other lessons, so it's not much new, but that's the biggest key thing. Okay, so for example, in the right underneath here, in the transformation, remember the capital R stands for reflection. Y equals 3 is the line you're reflecting that figure about, which, think about if that's a horizontal or vertical line. That's a big thing we're practicing right now. And Y equals 3 is a horizontal line because that line goes through the y-axis at 3. Okay, the next part of this says the capital T, which means a translation, and it just means you're shifting or moving the figure right, left, or up, down some. So in this particular one, again, the 0, I think I told you I usually put X, Y underneath the ordered pair. So the 0 and the X means you're not going right or left at all. The 3 and the Y means you're going up 3. And so every point is going to get moved up 3. But again, the new key thing here for this section is that you're going to translate first and then reflect the translated image. So you'll talk more about compositions in Algebra 2, but for now, this little circle in the middle is representing a composition. And again, in a composition, we are going to do the translation first and then the reflection. Okay, so that's kind of the key thing that we're doing here. And the other thing I just wanted to add in here is that okay, so yeah, that's the key thing here. It's just the translation first and the reflection second. Okay, and again, it says it right here. All right, a glide reflection is a composition made up of a translation followed by a reflection, which is, again, what we are doing right now. We're doing the translation first and then followed by the reflection. Okay, I'm going to include a little more in here under glide reflection, if you'll write that in your notes as well. That's just some good reminders. So a lot of times people will forget when they're doing a reflection which way the line goes, if it's horizontal or vertical. So I'd like to review over that again here. So for a reflection, if I have a coordinate plane, if my X and Y axis are not already labeled, that's the first thing I do because I don't want to forget which one the X and Y axis is. And then we have to kind of remember what we've been talking about here. If it says X equals 0, okay, that means that is the line that goes through the x-axis at 0, which is actually the y-axis. Okay, which is also a hint that anytime the line says x equals a number, and that number could be 5 or 3 or -2, it doesn't matter, it is going to be a vertical line. And don't forget, vertical is like an up and down line. Okay. Then if the line says y equals 0, that means it goes through the y-axis at 0, which technically is the x-axis. And that is also a good reminder that anytime it says y equals a number, whether it's 2 or 5 or -3, that it is going to be a horizontal line. And the way I keep straight, which is horizontal, which is vertical, a horizontal line is like the horizon. If you're at the beach, you're looking at the horizon, that's the right-left line. Okay, so that's a good little review there. So now if we move down to example 1, this is actually the only example we're going to do of this, but like I said, there's not much new to it. It's kind of a longer problem, but there's not much different than what we have already done. So if we read the problem, it says triangle ONM has vertices, and they tell us where O, N, and M are. We'll plot those in a moment. What is the image of triangle ONM for the glide reflection? And we see the glide reflection. So big key thing is that we want to remember that this one is done first and this one is done second. Kind of weird to go backwards, but that's a big key thing. Okay, the other couple little things that I want to remember is that when I do the translation, this is my x direction, my right-left direction, and this is my y direction, my up-down direction. So if I look at 5, -1, if 5 is my right-left direction, it's positive, that means I'm going to go right 5. Okay, if that -1 is my up-down number and it's negative, I'm going to go down 1. So I'm going to plot my original ordered pairs, then I'm going to do the translation, move every point right 5, down 1, and I'll label that O prime, N prime, N prime. And then that new figure that I have, I'm going to reflect about the line y equals 0, which we just said is the x-axis. Okay, and then I will get my third triangle in the picture, and I'll call it O double prime, N double prime, M double prime. And then I will fill in the ordered pairs off to the left here as part of my answer. Okay, so my original triangle is the ordered pairs are lifted above. Don't forget, anytime you're graphing a point, it's the x first and then the y. I think that's helpful a lot of times to put underneath here so you don't forget. So O is -4, 2. So I'm going left 4, up 2. And there's my O. My N is -1, 6. So there's N. And M is 0, 3. So I'm not going right or left at all. I'm going up 3. And there's my M. I can connect my points. And there's my original triangle. Okay, again, the first step is doing the translation, which is, again, I'm going to move all the points right 5 and down 1. So I use red for that. So if I take O and I go right 5 down 1, 1, 2, 3, 4, 5 down 1, there's my new O, and I'm going to label it O prime. N, I can move 1, 2, 3, 4, 5 up and down 1. And there's my new N. And M is 1, 2, 3, 4, 5 down 1. And there's my new M. Okay. And now they are asking for the ordered pairs of this new figure, so I need to write the ordered pairs. Again, don't forget x direction first, y direction from the origin. So from the origin, which is the spot right here where the x and y axis meet, I can go for O, right 1, up 1. So 1, 1. My N is right 4, up 5. And my M is right 5, up 2. So 5, 2. Okay, now from the red triangle, O prime, N prime, M prime, I am now going to do the second thing, that I have listed up above, which is reflecting about y equals 0, which is the x-axis. So I like to go ahead and highlight the x-axis. If the x and y-axis are not already labeled, I like to go ahead and label those. And here is my x-axis. So I'm going to reflect the red triangle about the x-axis. Again, all I do for reflection is see how far away each point is from one side of the line of reflection and then take that point that far on the other side. So if O is 1 away from the line of reflection, I'm going to take it 1 on the other side and label it O double prime. If N is 1, 2, 3, 4, 5 away, I'm going to go 1, 2, 3, 4, 5 on the other side. And there's my N double prime. M is 2 away. So we're going to take M 2 away on the other side and call it M double prime. Okay, go ahead and connect your dots for your new triangle. Make sure the triangles all look like the same shape and the same size, and they do look like that. Don't forget for a reflection, the purple and the red triangle, if you fold the paper along the x-axis, the line of reflection, those points should match up exactly if you've done it correctly. So that's a good double check. And then now I just need to label the ordered pairs of my purple triangle. So O double prime is at 1, -1, x direction first and y direction. N double prime is at 4, -5. And M double prime is at 5, -2. Okay, and that is it for section 9495, composition of isometries. At this point. So we'll do some more practice with that, and you can let me know if you have any questions. Thanks.